Welcome back. Going over Basic Sheet 1 from Module 2 of the Keystone exam. We're going over questions 5 to 9 on this one. The first one, this equation is in standard form. You have your x's first, your y's, and then your constant. A's positive. There's no fractions at all, so it's definitely standard form. But I want to change it to slope-intercept form, which is y equals mx plus b. It's the one I like the most because it's the easiest one to graph, which means you need to solve it for y. To solve it for the y's must be first. My x's are first right now, so I need to take them to the other side after the equal sign. So a positive 3x, if I moved it over, would become negative. So I'm going to have 5y still, equals, but now after the equal sign, I'll have a negative 3x, and there's still a 9, and that 9 is positive. Now to solve for y, I need y by itself, so I need to get rid of the times 5. So I will make sure I divide everybody by 5. When I do, I get y equals, this number is the slope, so it is okay to leave that as a fraction, negative 3/5 x. This one is your y-intercept. You may leave it as 9/5, or feel free to divide that out and say that it's 1.8. If you'd like. Some people like to have that divided out. It makes it easier for them to plot the y-intercept when they graph it. This also says up here, list the slope. The abbreviation for slope is m, and the slope of this line that you can find really easily once you solve it for y is the number in front of the x. That's your slope. Rate of change is a fancy way of saying slope. So that's a real easy question. The next one, I want to find the mean. The shortcut symbol for that is x with a line above it. Median, MED is the abbreviation. Range is the highest number minus the lowest number. Interquartile range is Q3 minus Q1. Mode is the number that occurs the most. Q1 is quartile 1 and Q3 is quartile 3. I'm going to let you know that you can do these on your calculator. So you're going to turn your calculator on, hit the stat button, edit to put your numbers in. I have stuff in mine right now, so I'm going to go up, hit clear, enter. I don't want to hit delete and delete the whole column. So go up, clear, enter. In list 1, I want to put the numbers. 7 is the number of the problem, so my first one is 2. So it's 2, 10, 1, and I'm hitting enter after each one. 14, 7, 2, 2. I have one list of data, so I'll hit stat, calc, number 1, var stats, and I just hit enter. My mean is that first one, that's 5.43. You can also find that by adding all the numbers up, pressing equal, and dividing by how many there are, which in this case are 1, 2, 3, 4, 5, 6, 7. My median, if you scroll down, all the important numbers are a little bit farther down. Your minimum number is a 1. Quartile 1 is a 2, so that's over here. Median right here is a 2. Quartile 3, which is listed here, is a 10. My max is 14. So let's go to range is my highest, or my max, minus my smallest. So 14 minus 1 is 13. Interquartile range you find from subtracting Q3 minus Q1, which is 8. And the number that occurs the most up here is a 2. Just a heads up, the 5-number summary, the most important numbers from here when drawing box and whisker plot, are actually all in order. They are the 1, the 2, the 2, the 10, and the 14. Right there are your 5-number summary. If you're, right there is, I should say, your 5-number summary if you need to make your box and whisker. The next two are about probability, and some of you are really familiar with a deck of cards. If not, I have these made that you can use. Question says, what's the probability of choosing a king or a heart from a standard deck of cards? I always think it's good to look at it. You're picking one time, so you want make sure you count every king and every heart that's in the deck. So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 that are hearts. And I already counted one of the kings, so I don't want to count that again. So it was 13 all the way across, 14, 15, and 16 out of 52 cards, which you can reduce on your calculator. Alpha y equals 16 over 52 reduces to 413. So the key is, if it's an OR problem, make sure you count every single one, but don't count any twice. Number 9 is different. What's the probability of choosing a king and then a queen from a standard deck of cards without replacement? Now, I wrote without replacement, but to be honest, that should be assumed unless they say otherwise. If they want an and probability, like you're doing two things here, you're picking two cards, then I need two fractions that you're going to multiply together. What is the probability of choosing a king? Well, there's 4 kings out of 52. So you have a 4 out of 52 chance. Now, I already picked a king, let's say, and now I want the probability of picking a queen. Well, there's still 4 queens there, but the second time I pick, if I did not put my king back, I only have 51 cards. So I need to make sure I reduce this by 1. I don't need to reduce the top because there was 4 kings and there's still 4 queens. I only picked a king. I didn't pick a queen already, so I'm in good shape. So I go right to my calculator, and I'm going to put in 4 over 52 times 4 over 51. My answer comes out to be 4 over 663 on my calculator. Now, you can divide that out and get a decimal. However, I find that most probability questions are fractions. So there is the second side of your basic sheet for Module 2.